Hello Legacy Sabers, Marsh here. So today we're going to talk about variables and arithmetic, basically how to do math with Java. So first things we want to get past, there is the possibility to declare multiple variables of the same data type on the same line. So I can write something that looks like double hours, comma, rate, comma, total. So that would allow me to make three separate variables. I made a variable for hours, rate, and total that are all a double. That's why I can do that. Variables can also be initialized at a given value during these multiples. So I can go double hours equals 35.5, comma, rate equals 8.0, comma, total. So notice total, I didn't initialize, I didn't give it a value. However, total will get a value automatically with the value of 0. So keeping that in mind that is available. Now, it's not required. I find that I usually make multiple variables on multiple lines. That way I can kind of pay attention to which ones are made and available for me to use. Another thing that we also want to know about is that we can make a constant. A constant is a variable that has a value that cannot change throughout the program. So maybe it's the total amount of pounds allowed on a road. Maybe it's pi in math. Anything along those lines would be available to us in our program if we wanted to make a constant. To accomplish that task, it's going to be the word final, and then depending on what variable type you want, and then notice the name of my constant is in capital letters. This is just more of a, no, what's the word for it? A courtesy. It makes it easier, makes it stand out for us, so that way we know that because it's all capital letters, we do know that it's a constant. We can't change it. That way we don't have to scroll all the way up to the top of the program going, well, why can't I change that? Because it's a constant, okay? It gives us that changes it enough that we can recognize that. The other thing that you have to assign a value to a constant when you create it. These should only be used if you know the value will never change throughout the program, and it has to be a value that you found to start with. You can't get a value from the user and then make the constant with that. It has to be a value, an actual value that you know at the start when you make that constant. Now, let's get into the meat and potatoes of this information today. We need to talk about arithmetic operators. Arithmetic operators, the various things that you can use math for. So adding and subtracting, no surprise there, right? Multiplying, though, this is the asterisk. It's the key on the 8. We have to use that instead of a multiplication because x can be an x, right? Dividing is exactly what you think it is. And then modulus, the remainder. We need to talk a little bit more about him. The modulus guy, so like let's say if I say 17 mod 3, okay? What's going to happen is this is division. So it's going to take 13 divided by 17, right? And then we got to ask ourselves, how many times does 3 go into 17? Well, that would be 5 times, right? 5 times 3 is 15. The remainder, or what modulus would return, is the leftovers after you divide. So 17 mod 3 would give us a value of 2. That is very helpful in the regards of you want to see what's left after you divide. That could be used for, let's say, a program that decides how many hours a movie is, or what's the running time of a movie. A lot of times if you look on the back of a DVD, it usually said like 123 minutes. It doesn't say how many hours and how many minutes the actual thing is. So we need that modulus remainder to be able to give us the leftovers after I divide. That's what he's the most useful for. And order of operations still held. So just like order of operations is in our programming class or math classes, we also have them in programming. Operators within parentheses are going to be performed first. They are nested parentheses, so the innermost operators can be performed. And then normally, just like always, multiplication, division, and modulus are going to be performed next, left to right, and then plus or minus. This is basically your PEMDAS of programming, okay? So same thing, same rules. We're not going to change our rules at all in this PEMDAS in programming. Now be careful. Make sure that if you are using PEMDAS, make sure that you are using parentheses where you need to have happen. I see a lot of kids that you make averages and they forget that it's not going to add first and then divide. So keep that in mind as you're working. We've been already using these, but I just wanted to give you a word for them. Assignment statements is when it's used to assign a value on the right-hand side of the equation to a variable on the left. The command used to create an assignment statement is the equal sign. So the general form of assignment statement is variable equals expression. So something like, well, int Bob equals 2 plus 3. This would be an assignment statement. This is my variable that I just made, and this is the expression that I am assigning to Bob. Because the equal sign is an assigning. You're giving it a value. You're not making it equal to that value because that value can change, but we're assigning it that value. Now, there are compound assignment operators that we can use very commonly. So you got your simple assignment, and then you have this compound addition. This is super useful in the regards of less typing because we're lazy by nature, right? We're programmers. We like to be lazy. So these compound ability allows you to change the value and then reassign it to the variable you're using. So let's say we want to add 5 to a score. So I'll take the current score and add 5. These are what they're doing. So normally I would have had to write an assignment statement of x equals x plus 10. Well, if I use my compound assignment, I can go x plus equals 10. So that means I'm going to take x, add 10 to it, and put it back into the variable x. Makes it a little easier to read, and it's a little less typing. Not by much, but nevertheless, it makes it easier for us to read, a little easier to type, and also less mess-ups possibilities. The other ones that are very, very, very useful are increment and decrement operators. Increment and decrement allowed you to add 1 or subtract 1 to the value of the variable. These can be used on integer, floating point, or character variables as well. So increment is plus plus or minus minus. So equivalence would be x equals x plus 1 or x plus equals 1. So if I wanted to happen for an increment, I would go x plus plus. That's just me saying, hey, add 1 to x. That makes it a lot quicker, a lot easier to read. But again, if this doesn't work out in your brain, you have 2 other options to accomplish with. If I want to do decrement, it would be x minus minus. So that allows us to add 1 or subtract 1 to the value of the variable. Let's also talk about numeric type conversions, also known as typecasting. So when I perform arithmetic operators with unlike data types, so like let's say I add an int to a double, right? The Java language chooses a type for the result, and it's going to be in this order. So if I have a double in there, it'll make a double. If there's a float, long, int, so notice ints are kind of low on the board. So if I add an int to a double, you will get a double. If I add a double to a double, you'll get a double. Here's the problem though. Let's say I add an int to an int. You're going to get an int. Now you're like, that's not troublesome, but what about division? This is important with like types. If I divide an integer by another integer, your answer will be of integer. So if I divide 7 by 4, you're going to get 1, not 1.75. And this is the most frustrating thing about Java because you're like, no, 7 divided by 4 is not 1 Java. But here's the thing. He sees that 7 and that 4 as integers, and he's going, I'm sorry, I can only give you an integer back. So in this case, 4 divided by 7, that's 0. 1 divided by 2, that's also 0. So this is going to make our lives kind of difficult, and it's very common that we as programmers will forget that this exists. So we got to be super careful as we're working through this. Now you're probably asking, how can I make this not happen? Well, if you don't want this to happen, you purposely have to override the unifying type by typecasting. So right here, I got int balance equals 189, and I have to divide that by 4. Notice what I'm doing right here. I am purposely making balance a double. I am tricking Java into saying balance is a double. It definitely is. Because then what he'll do is he'll go, oh yes, double divided by an integer, totes, that's a double. The other way I could trick Java into doing this is I could say balance, which is an int, divided by 4.0. This is a double. He sees that decimal, he's like, ah, yes, double, yes. Now you're probably saying, Marsh, 4 and 4.0 are not different. And I'm going to say, you're right. But according to Java, he thinks that that is different because of that decimal. He thinks those are different data types. Same thing I can do. I can also put int in front of something, and I can force it to be an integer. So with weekly budget, which was 47.25, I can int that, typecast it to an int, and it would make it 47. So it's not going to round, it's literally going to truncate. What I mean by truncate is cut the decimal portion off. So if you typecast to type int, you will truncate the decimal. You're going to cut the decimals off the value. I know, super fast conversation here on this information, but we're going to do some examples together so that way you guys can get used to using this information, and we'll continue with our programs as well. But until then, I will see you later, Sabers.